Hi, my name is Ali. Let's talk about NSX ALB, which is a networking solution from VMware. Um, and today, specifically, I want to quickly focus on NSX ALB for TKG. So lots of lots of abbreviated terms there. The TKG stands for Tanzu Kubernetes Grid, and NSX ALB stands for NSX Advanced Load Balancer. Right? It is not NSXT. A lot of the time we get confused about when we say NSX, we get this one mixed up with NSXT, which is a different set of tool set, which is also in the networking space, but different set of tools. So what this NSX ALB is, so if I go to the documentation page, or if I just search for VMware, VMware NSX ALB, it'll come up with NSX Advanced Load Balancer. So let me go into the page. So it talks about NSX ALB in great details, and it's pretty good. I've been playing with it for some time, and the more I see it, the more I get impressed about it. NSXT, as I was mentioning, that this is not NSXT. So this is the NSXT page, right? Which is again a different set of product suite than NSX ALB. So there's a data sheet about NSXT. So I'm not going to go into too much detail about the difference between NSX ALB and NSXT today. That's a topic for a separate day. But what I want to focus on today is how we can use NSX ALB for implementing Kubernetes functionality on vSphere environment. So as we know, Kubernetes, so if we just imagine we got an infrastructure layer that is based off of ESXi host, and that brings up the capability of virtualized storage, virtual machines, and distributed switch and distributed port group, then we can think about like when we implement NSX ALB on that environment, it's going to interface with the VDS and VDPGs, right? And then when Kubernetes comes in, as we know that in order to access the Kubernetes service from outside, which is a service type construct, that interfaces with the load balancer, and load balancer interfaces with the virtual switches, right? And that's how we get access to the Kubernetes containers running inside Kubernetes. So again, just to summarize, so when you think about Kubernetes layer, we are actually talking about a bunch of pods, right? So these pods, the way we can access these pods or the container running inside pods is exposing them to a construct called service type load balancer. When we do that, that interfaces with the L4 layer, which will be provided by NSX ALB, and it exposes that service to the external to Kubernetes world, right? So NSX ALB does addresses this L4 level load balancing capability in a very interesting way, which is, let's say we have a Kubernetes cluster, and we need to access a workload running inside Kubernetes cluster. So what will happen inside NSX ALB in logical scenario is we have a concept called NSX ALB controller, which is also known as RB. So I'm putting the RB controller, but it's the same thing. And the controller actually creates something called a service engine. So the service engine is actually the VM, which runs the algorithm to create the load balancing construct. So the load balancing construct is actually called virtual services. So the moment Kubernetes cluster gets created, the API endpoint itself needs a virtual service. So that gets placed onto one service engine and gets backed up or fall back onto a second service. So the minimum 2 service engines run. And then when we create, like, Kubernetes creates service type load balancer, it creates another virtual service, and that's the end user accessing Kubernetes service of type load balancer using that virtual service, right? So it's very distributed architecture, and also we can create a cluster of the controller. So that's where we can ensure that the controller itself is highly available. So that what that means is whenever a service goes down, the controller knows about it, it's automatically going to spin up that service, right? And if in bizarre scenario the controller itself goes down, the service engines are still up and running. So that means we haven't lost the connectivity to our Kubernetes environment or the application running inside it. So that's pretty good from architecture perspective. I really like this distributed architecture, how NSX ALB kind of addresses that issue. So let's do it. So let's see how we will install NSX ALB on our vSphere environment. Okay. So a couple of prerequisites. The vSphere environment must have a virtual distributed switch enabled. Otherwise, there is a lot of automation that kind of takes place under the hood that won't work. So we need to have VDS. It can work with VSS, but you know there's a lot of manual steps that we need to do. So I'm not gonna. I don't even know like what those manual steps are. But with VDS, things are quite simple, and we need minimum of 2 virtual distributed pod group, right? I usually use 3. Which is one is the management. This is where my vCenter exists, and I'm going to deploy the controller onto the same pod group. And then we've got 2 other networks, which is the front end. So this one is, when you see the documentation and everything, people in the documentation they will be referenced as VIP or virtual IPs or data plane. So that's actually the front end. So this is where our virtual services will get created, and it will. So these things will get the IP addresses from the front end, right? And we need a Kubernetes backend. So this is where when this network will actually ensure that when a VM gets spun up for a certain cluster, it gets IP addresses from a separate set of subnet. Now I could have mixed all it in one network, but at the very least, we need to have front end and back end networks separated, right? So creating and configuring NSX ALB is pretty easy. So I'll quickly show you the setup that I have in my one of my lab environments. So the environment that we're looking at is one region, one cluster, very minimum setup, and I have, oh, that's just vSAN stuff, and so on the networking side, so we need to prepare our vSphere environment first for NSX ALB to be deployed. And for that, as I mentioned, virtual switch is a must, is a requirement, is a prerequisite to that. So I've already got that configured, and I have several port groups, but the ones that I'm going to use is the front end, the workload, and the management. Okay, so these the 3 virtual port groups are already configured, and now I'll get started with the actual setup of the NSX ALB. All right, so as I was explaining, that this is how, if I visualize it, this is how my networking will look like. So I have vCenter and RV controller, both of them are deployed on the same network. When the controller will spin up the RV ACs or NSX ALB AC service engines, it will get automatically spin up. I don't have to create it manually for Kubernetes in the Kubernetes scenario. But if you want to create it manually, that's also fine. Let's say you have a couple of VM-based workloads and you want to create a load balancer for it, go for it. That's all good. It will get created in this network. I can configure it very differently and have segregated networks as well, but in this video I'm just going to keep things super lame and super simple. And then I will dedicate one more network for the virtual services. So this is where our Kubernetes service type load balancer would get exposed, and the workload network. So this is where when VMs will get created, they will get their IP addresses from. Right, I have a routing rule that's I'm going to set up, which will tell how to route out to the internet. So that's pretty much it. Very, very simple, right? So first things first, I'll need to download the OVA file. So the way to download this one is you go to my VMware, so my.vmware.com, and so that's this page, and I'll go log in. So I'll pause this video and I'll quickly log in, and then I'll get started. Okay, so I'm just logging in, and then this is the URL where I am going to download the NSX ALB for, the NSX ALB OVA from. So if I go products, all products, and and that says VMware NSX Advanced Load Balancer, I'll go to the download section, and if I go download now, it will take me to the ARMY portal. So wait for it, and then under software, and there are a bunch of versions. So at the time of when I'm recording this video, the version that works without any workaround is 20.1.7. So I've already downloaded that OVA file, which is this one here. So basically you just go into the download section and scroll down to the OVA, and it just download that OVA. Okay, pretty straightforward. And then I go into my cluster, and I go deploy OVA template. Because I've already downloaded it, I'm going to the local files and upload that file. Okay. I'll name this, not controller, I'll name this NSX ALB controller 01A. Go next. Yeah, sure, I've only got one one cluster in one region, so that's all good. It'll take some time here to actually get the next prompt up, because I'm guessing like it's trying to upload that OVA file. Oh, there you go. And then I go select storage, and I got a couple of options there. So I can do this one, and default storage, I will add that in this storage. And go next. So I'll put that onto the management. This is management, and here now it's asking for what's my management IP address. So as I was showing you here before, that the management plane IP address. So we haven't got to that point. So this is now we're deploying the OVA at the moment, and it says management interface IP address. So I'm going to give the IP address this one, which is, if I look at the diagram that I had, so the plan that I put in place, which is this network, right? So this is 192.168.110/24. So use the IP address from there. Obviously this subnet gateway is this. Default gateway. So I have a default gateway, which is the gateway of this subnet, which is the first IP of that range. This is the authentication key. It's an optional optional config. The rest of it, it's about integrating it with NSXT if you have NSXT for your layer 3. I don't, so I'm going to set it up on VDS and VDPG based. So I'll stop configuring up until this point. It talks about, like, you don't. And then I go next. So that's pretty much it. I go finish, and now it will take some time to get the OVA uploaded, and it will show up in a bit. So the process has already started. I'll pause the video, and when the process completes, I'll come back to it. Okay, so now the OVA has finished getting uploaded, and I can see if I just click them over around. So it's powered off right now, and I've got actions to power it on. So I'll just go ahead and do that. I could also make it templates before I did that, but that's okay. This is in an environment. I'll probably get rid of it once I've done recording this video. So I'll pause the video again, and once it's powered on, I'll come back to it. Okay, so now the OVA is fully powered on, and I can see the IP address got assigned, the one that I configured when I uploaded the OVA. So I'm just going to copy that IP address and open up a browser tab and just go to that IP address. Okay. And it will take me to the ALB controller console. Because this is the first time I'm accessing it, so it's prompting me to create admin user. So the username is going to be admin. Password is going to be my super secret password. Email address. Controller has a functionality to email, to send an email about certain events. So I'm not going to configure that in this video. So I'll just go ahead and create this account. And then let's talk about system settings. So I'll put the same passwords. Now, on the DNS resolver side, I can put in the IP address or the list of DNS server that I have. So I do have a DNS server set up in my environment today. So if I go into DNS, so that's the DNS server I have. Okay, and the server is actually on the host itself. So I've got an IP address for that, which is 192.168.110.10. So this is where my DNS server is set up on the DNS search domain. So I have, I think it's probably core.tanzu. That's my live environment. Core.tanzu, yes. So I will set that up. Core.tanzu, that's my search domain. This one, as I mentioned, I'm not going to do the email settings right now, and I think that's about it. So I go save, and then will get me to the controller page. So I'll quickly switch back now that we can access the controller. So what are the next things that we need to do? Okay, so I've deployed that. I could access it using IP address, and or I could map that IP address to a DNS name, and I could access it through that, which I have mapped, which I'll get to it in a bit. So now I've already done this part, so this is done. So that's done. Activate license, so that's my next step. Right? So I'll go in and go to the licensing section. I think it's under settings, licensing, and as I've just downloaded from the Customer Connect portal, it came with a certain set of licenses, which is 20 service core. So for this demo purpose, this is okay, and this is an evaluation license which will expire in a month time, but that's fine. That will work for me. If I had a license key, that's where I would apply it. So that part is done as well. So that's done. connect and configure cloud. So that's my next step, right? Okay, so before I get to that, sorry, yes, so connect and configure cloud. So in order to do that, I will head over to infrastructure, clouds, and there is a default cloud options which is not connected to anything at the moment. It's just showing green because it's just a controller by itself, not connected anywhere, so it's thinking that it's all good. But we're going to change that. So our cloud is VMware. I go next, the username. So this is the username to connect to this vCenter client, right? To connect to this server, this cloud. So I am an admin user. Make sure that when you do this, the user that you're going to use to connect with the cloud or connect with your vSphere environment, make sure that's actually has got admin privileges. Local. There we go. There's always a possibility of fingering things. Administrator, yes, so that's my login. My super secret password, control center address. So this can be an IP address or an FQVN. Right? So I'm going to use the hostname because that's the one I will use when I'll set up Kubernetes as well. So I'll use the hostname for it, not the IP address. So easy way I can find that out is this hostname here, the hostname that I'm using to access the vSphere client. So I will use that one. So get rid of the HTTP. It's just asking for the FQDN, so none of this stuff is needed. Alright, so access permission is right. IPAM, we'll get to that in a second, but for now that's all good. On the next step, we'll go to the data center side. So it will automatic, so it was able to connect to the client, and it automatically pulled up the data center information. As I only have one, so I'm just going to select that. And yeah, I'll just say no DHCP because I'm not going to configure using DHCP and so on. So I'll just go ahead. Now it's evaluating the settings that I've given it. Come on. Okay, so now it's asking for the management network, right? So as I mentioned, I'm going to select the management network according to this diagram that I showed before, which is this guy here. So that's going to be a management network, right? and the management network name is a D-switch management. That's the VDPG. So service engine group, I only have one group, so you can create multiple service engine groups for multiple purposes, but this is a super simple setup, so I'm going to stick with the default one. What else? DHCP enabled? No. The subnet is actually the management network subnet, so 192.168.110.0/24. Static IP address pool. So this is the IP address this is the range of IP address that the controller is going to use when it creates the service engines. And it will track the ranges and it will assign the IP address to that VM, service engine VM, from this range. So I'm going to give it 168.110. let's say I can start with 120 until 139. Let's say that's big enough range, and that will get me quite a lot. It will also depend on how I configure the service engine, how many virtual services I allow it to run on one service engine. But for the demo purpose, I think this is okay. 192.168. So that's my gateway there. That's pretty much it. I got save. Okay. So now this status is yellow. It's like suddenly turned to yellow and then green. That means it's now successfully able to connect to that. So we're good. Now the other thing I will do, again, this is possibly an optional step, but I'd like to do it anyway, just to show how we can configure that. Is if I go into administrators, I'll configure the cluster. Remember this this diagram that I showed, this one. So I can configure a controller cluster that will make sure the controller is always highly available. If one VM goes down, the other one is always, the other one gets elected as the leader, and that controls. So I will configure that in here. I think it's under controller. I will go, oh, so it's kind of trying to pull the status of it. So that's active status. I will edit. And this one I'll just name it cluster 01, controller cluster IP address. So this is where I'll put 192.168.110. I believe it's 31 that I have set up in my DNS. Is the cluster, so that's 31. Okay. The reason I like to actually do this, regardless whether it's one controller or multiple, is actually it gives me the flexibility to access it via the cluster IP itself and not the controller, not directly the controller. So if I add more controller in future, then this doesn't change, right? So that's a good thing. So I'll keep that. The rest of the things are possibly will remain the same. So this one remains same, name of it. So that's the IP address. I'll just name it as it is. The password to access this controller is the password that I set up for the admin user. So the password is always for admin user. And the public IP, because I'm in the private cloud, so I don't have a public IP, so I'll just leave it blank, and that's about it. So that's it. I've got my cluster done. So I'll just tick that off. So that's done as well. Controller cluster is also done. Now I'm going to configure DNS and NTP. Right? So one of the prerequisites that I forgot to mention, that I must have NTP server available in my environment, and I need to configure RV with that NTP server. And there is also DNS server, which is optional, but it's like in my case, I have a DNS server, so I'm going to configure DNS server with it. Apologies, like I've already gone ahead and configured the NTP server, so I'll show you what that looks like. So if I go to administrator settings DNS and click on edit, by default there is 4 DNS server that's available. I deleted the 3 and I only have 1 server, which is my NTP server. And I'll just double check if the is actually, if I've got the IP address right. I'll just try to do ping 192.168.1. Yeah, so I've got an NTP server running there. So I'll use that IP address instead, right? Get rid of the default one, because that's never going to match with the cloud's own NTP server. Always use the cloud's own NTP server. So in my case, I've got this one already set up. So I'll save this one. So that's the DNS and NTP's configuration done. DNS I did not need to configure, because it automatically pulled it from my previous configuration screen that I did in previous step. So that's now done, and I'll just check those two boxes that I've done that. So this is now done. Okay. So that's now done, and now the optional stuff is configure backup. Right? Now this one is optional, but for the demo purpose, I'll quickly show where that is and how to do it and what does it mean. So I'll go into system administrator. So I'm already on the administrator section, and I'll go under system, and there is this configuration of backup, right? By default, it says backup every 1 day for maximum backup restores. So what this one actually does is it will create a backup of the controller and its settings. So if any scenario disaster happen, we can recover from this backup, right? So I'm not going to change here much, except for the frequency. It says every day, and backup up to 4 times. So I'm going to just change that because this is a demo scenario. So I'll just say every 7 days is fine. And the number of backup restores, I'm just going to say 2 is okay, right? And backup destination is local. So that means wherever the controller is running, that's where I'm going to backup, which is not recommended. This is just a default settings. So I can take that off and I go remote server. The remote server could be any other backup location that you have. So for this purpose, I'm going to stick with local. So now we know what the backup is, and passphrase, I'll use the same password as the admin. Okay, save. So that's where the backup is. And say 7 days, maximum of 2. So that portion is ticked, done. Next up is configure certs. So in order to do that, I'll go in administrator, templates, security, SSL TLS certificate. That's the first tab there. I already have a certificate created from an existing certificate authority. The first thing, to use that certificate, I need to first upload the certificate authority. Right? So I'll go and use that, and I'll call it, I'll actually forget the name, I'll remember the name in a bit. So the authority that I have is controller cert. So I'll go CA controller, and I'll do validate. It's called controller CA. So I'll just use that. So CA controller is controller CA. So that's the name, and I'll import. Right. So I've got the controller CA there. That's all done. Now I have to upload the application certificate. Import and the certificate I generated previously. So I'll upload these 2 files. And the name of the certificate, let's call it Tanzu Wildcard. Okay. I do validate. So now I've got the certificate there. Yeah, looks good. and I apply that. So that's, so now I've got the certificate against Carl.Tanzu. The reason I did this, sorry, Carl.Tanzu and controller CA is coming from there, right? So the reason I did this, which will make sense in a bit, because I have a DNS configured like that. So it is this. So that's how I'll access. I'll use FQDN to access access the controller, so that I can. So this goes away, the not secure one, and of course, like when Kubernetes or TKG will try to access it, then this will also. We can also have a not secured connection. So these two are now configured. I think this is where, oh sorry, I'll mark it, this one as done as well. So next up is IPAM and DNS, but before I do that, and in order to use the recent certificate that I just uploaded, I'll go into administrator settings. Is access settings page, right? So this is where all the certificates are configured, and it says SSL-TLS in this area. So this is where I'll use the certificate that I created. So get rid of these two. Don't need this anymore. And I should be able to find my certificate here. That's a mistake that I made. Okay, so I made one more mistake. It's so easy to make those mistakes. So I go templates, security certs. So this certificate I uploaded as a controller CA. Sorry, as an application CA, whereas I actually needed to upload it as a controller CA instead. So I go controller CA. Will upload and search. This one, I'll still name it Tanzu Wildcard. So they'll remain the same. Validate. Same, because I've already done that. So now this should show up in my administrator settings, access settings. Okay, so now if I get rid of this too, now it's there. So that's a controller CA, not an application CA. So that is a mistake on my part. Apologies. Okay, so now I've got the Tanzu wildcard selected there. I save this. Sorry, one more thing I need to do in here is tick this box, basic authentication. So this allows Tanzu Kubernetes Grid to automatically authenticate with the controller and instruct it to create virtual services, which will trigger creation of service engines. Okay, so I go save. Come on, what's wrong with you? That's because I changed the certificate. That's okay. So I'll go with this. So it reloads because now the cert is different. That's fine. So I'll go basic authentication. I can save it now. Okay, so that's now done, and that certificate actually does not use this IP address, hence we're still getting the not secure warning in here, which will, if we try to access this IP address from Tanzu Kubernetes Grid as well, or we'll set it up, it will become quite eminent, is it will also fail. So what we now need to do is we can now use the FQDN that we set up previously. So this FQDN here, to access this page. So close this browser, open it again, so that refreshes all the logins and everything. Now go through this. All right, so see now I don't actually have that warning coming up because this FVDN is mapped in that certificate. Right? So just go admin and my password there, so that's done. Cool, so now I can access it. So now the certificate create part is properly complete, so that's done. The next step is IPAM and DNS profile, right? So to do that, I'm going to go to templates, IPAM and DNS profile, let's create the IPAM first, and let's call it default IPAM because I only have one front end. And I'm going to use the cloud here. Now, the reason I'm creating this IPAM profile is when the virtual services will get created. So if I look at the diagram, so I've got a range of IP addresses in here, right, which I have not configured yet. I am going to. So NSX ALB needs to keep track of how many IP addresses it has used and how many is available and what are the IP addresses it has used. So when it pulls from this range, it pulls a non-used IP address, a not used IP address, I should say. So that's why that's what the IPAM profile is all about, right? And I am going to use this IPAM profile on Kubernetes front-end network because that's the network it will use to create virtual services for. That's the automation side of things. Okay, so I'll save this one, and I can also create a DNS profile. Now, in this demo, I won't be able to show. I won't show how this DNS profile will come into play. I'll make a separate video about it. But for now, I'll just create the profile, default DNS. So this is where I'll tell you like why this DNS profile is we need this DNS profile is when we can with NSX ALB we can also do DNS delegation. So that means whenever a new load balancer is created, a SLB will be able to create a new DNS record for it. Not in the DNS server, but this record it will manage in itself, right? So I can give something like, let's say, lb.conf.zip. I can do that. Default level, I'm not going to overwrite this, so this is fine. I'll just do save. So this is done. Now we have created the profile, but we need to link it. Right? So we go to our clouds and we'll come here. Remember this section we said like we're going to look at it later on. So now I'll just link those profiles that I created. Okay, with our cloud. So that's done. When we have multiple clouds, we can create multiple profiles. So this is where the profile concept comes into play in NSX ALB. The last piece is actually configuring the networking. So if I go into the list of the things that I need to do, so this one is done. Okay. Now we need to configure the network. So if I go under network sections, infrastructure networks, this should automatically pull in the port group that is configured in our vSphere or vCenter, right? The one that we showed you before. These guys, because the cloud is not connected, is now connected, right? So what we need to do here is just provide it with the IP ranges that is usable that we're going to use for this. So the management IPs, we have already set it up, so you can see the ranges we have given it before. What I'm going to do is set up the front-end network, because I'm not going to use the entire subnet for it, right? So I go add subnet. Subnet is 192.168.20.0/23, as we saw it before. This one, one of the things that I'll recommend here is have these things planned out. What are the IP ranges that you're going to use before you dive into setting this up, because there's quite a lot of setup that we go through. And 192.168.220.2 from that range to, so I'm just giving it a range that it will use in the IPAM profile. 168 to 20. Maybe 127. That's massive. Okay. Or what is the range that I planned before? Yeah, 127. So that's good enough in here. That's done. Nothing to do more. I'll just double check. Yep. And DHCP, I'm not going to use DHCP. Done. The next thing is the workload. Now, if there is a DHCP, we can use DHCP. That's okay. In my case, I'm not going to use DHCP. So this one is 130.0/24, and the range that I'm going to use in here is 192.168.130.2, because 1 is the gateway. 192.168.130. Let's say, because there is always going to be more VMs than the virtual service itself, so I will give it a big enough range. Okay. I think that's it on this case. So in this scenario, RV will act as a DHCP server, because I've given it not as a DHCP, but it will be able to, it will know what are the range that it needs to use for the Kubernetes virtual machines, Kubernetes nodes, essentially. So that's configured as well. So I'll tick that one. Completed. The last one is the routing. So I'll go routing, and I'll create, I could do default gateway. /24/0. Which one is the default one? Yeah, it must be /0. And I could route it out through 192.168.220.1. So that's fine. That becomes the default gateway. So I could just get away with it. In case there is no default gateway, don't expose it like that. We could always do 192.168. The gateway that we have, 220.0/ on our 23 subnet, to 168.220.1. So I could always do that, right? And of course the workload subnet as well. So 192.168.130.0/24 and 192. So this one will hop through our front-end network. So depending on what sort of routing situation I have it going, I could use this as well. So that sort of flattens the network and routes through all through the same gateway. Right, but I have default gateway set up. So when when it will come down to route out, then it will use the default gateway anyway. It won't go in here, but that's okay. So that's pretty much it. That's where we have configured our NSX ALB to use for Tanzu Kubernetes Grid. One more optional configuration that we can do is actually configuring the service engine group, which I have missed out on this one. So I'll say, actually it's not done yet, so I'll say optional configuration, right, which is the service engine itself. Okay, so what I mean by that is if I go to the service engine group, there's a default group, so by default this is going to get used. If I edit this one, by default it's going to do NNM buffer. I can do active and all that sort of settings there. I think the settings are pretty much self-explanatory what they are. The thing that I want to configure here, and just to separate out, because I'm going to use this group for Tanzu Kubernetes Grid. So in order to do that, the way I'll do it is I'll go into advanced, and in here it says RV, right? And that's the prefix of the VM when it will get created. What I want to do here is I'll just say RV Tanzu, right? So now I'll have a prefix of RV Tanzu, so which will say, these certain groups of service engines that's getting created are used for TKG purpose, and then I can use another set of groups for another VM requirement. That's pretty much it. So I'll just save this one. And one other thing I can quickly do here is maximum number of service engines is 10. This is definitely not production ready for production, because as you can see, I'm just assigning 2 GB of memory, which is okay, which is pretty good, and I'm not even doing memory CPU reserve. But anyway, which is pretty good. Like when you think about a dev scenario, normal applications getting deployed, right? Load balancing a normal application, that's okay. Now it's a high traffic. When the traffic volume is high, that's where we can do CPU reservation, assign more CPU and more memory to it. So the VM itself has got more capacity to host the virtual services, the high traffic virtual services. But for now, I'll keep this as it is. Memory caching. The thing that I wanted to configure here is because right now it says 10 virtual services per engine, right? So that's the density of the load balancer that will be hosted per VM. Because this is a dev cluster scenario, so I can easily do it 20. Because in this case, like I'll deploy an application, I'll test it out, and I'll probably remove it. So it will never get to. It will possibly be more likely to be a not high traffic scenario. So that's okay. So I can increase the density. So in your scenario, when you see this kind of version where the traffic volume is lower, we can also do configure the density of the virtual services per service engine, which is pretty good. Like it's a fair bit of configuration, fair bit of flexibility there. The other thing I have is the metric update frequency. I can have real-time metric. I will go into that topic in a later video. But for now, I'm just going to keep things simple. That's pretty much it. So now, in a separate video, I will record of deploying a Tanzu Kubernetes Grid using this NSX ALB setup that I just did. And that's where this is it. So we now have NSX ALB set up and ready to go. When we deploy Kubernetes Grid, we'll just point it to this one. And we'll see there is no service engines right now, but it will get auto-created when we start deploying Kubernetes on VMware environment. And it will request for a virtual service or load balancer, which will trigger creation of service engine and a virtual service provision on it. So I'll record that on a separate video. Thank you.